Assalamu alaikum wa rahmatullah. Today, inshallah, we'll be covering something regarding chi-square and how to solve it and how to search for the givens. And some problems from the review pack will be solved. Actually, all of them. Yeah. طيب, let's share the screen. Chi-square test. So why are we using أصلاً chi-square test from the very beginning? Why are we doing so? Let's go here. You have two things to think about. One is called null hypothesis. One is called null hypothesis. And the other one is called alternative hypothesis. Null hypothesis, as if you are saying that the results that have been under investigation, they are not related to each other. They are not related to each other, and the outcomes came by chance. Alternative hypothesis, this is the one you are putting. This is your hypothesis. The one you are investigating, فعلا, this is your hypothesis. You are trying to validate your hypothesis. طيب, how can I tell that whether to accept my hypothesis or to reject it? In order to work with chi-square at the very beginning you have to work with those givens. Number one, you have some givens لازم يكونوا موجودين. One of them is the chi-squared value. Other one is the critical value, p-value, which is the probability, and the degree of freedom. Those must be all found within the questions. Seek to find them. Seek to find them. Also, what are we going to search for? أو use is the rule. If the chi value is bigger than the critical value, so you have to reject the null hypothesis. If the chi value is less than the critical value, you have to accept the null hypothesis. And the null hypothesis and the alternative hypothesis, they are they are opposite each other. They are opposite each other. If you rejected the null, so you're accepting the alternative. If you accepted the null, you're rejecting the alternative. طيب, fine. How can I get the chi-squared value? By using this formula. O minus e power of 2 over e اللي هي observed minus expected over expected, وهنا كان عندي power of 2, and the sum. Sum of what? Sum of all different phenotypes that have been given. This is called sum of all different phenotypes. But what about the degree of freedom? Degree of freedom equal phenotypes minus 1. So if you work at the Punnett square and you find مثلا you have 2 phenotypes, so the degree of freedom in that way it will be equal to minus 1 equal 1. If you work at the Punnett square and you have 3 different phenotypes, so the degree of freedom will be 3 minus 1 equal 2. Why do I need this? Why do I need this? Because if you get the degree of freedom, you are simply getting the critical value, meaning using this table. So for example, if you're having number of phenotypes equal مثلا طلع عندي 3. So I know that the degree of freedom would equal to 3 minus 1 equal 2. So here the probability, and as I told you, biologists will always use this. So seek to find this probability. This is the only range we will be working with, 0.05. And the degree of freedom equal 2. So the matching critical value would be equal to 5.99. So this is the critical value. Why do I need the critical value? Because you need to compare your chi-squared value to this critical value. If it's less than 5.99 or more than 5.99. If it's less than 9, لو كتبت هنا كده, if the chi value is greater than the critical value, or there is another scenario, if the chi value is less than the critical value. In that case, in the last case, it was the critical value was 5.99. If the chi value, مثلا, for example, was 7.8, so you have to say reject the null. What do you mean by the word reject the null hypothesis? As if you're saying that the data or the experiment under investigation, all the results have been given, they are not coming by chance. No, there is a relationship between the dependent and the independent variable. So as if you are rejecting the null. And if you are rejecting the null, what are you doing to the alternative? You're accepting the alternative. In the other way, 5.99 like in the last example, and the chi value مثلا كانت 3.8. So now you are accepting the null. What do you mean by the word accepting the null? As if you're saying that yes, the experiment under investigation, all the results came by chance and there's no significant relationship between the dependent and the independent. And if you accepted the null, automatically you are rejecting the alternative. Once again, if you would like to solve the chi-square, use this. Think about this all the time. كده within the exam أو during the exam يعني هيبقى normally you will be given the p-value. P-value is given. Why? Because it's found within the table. This is a table 0.05. The degree of freedom is easily calculated. Why easily calculated? Because you know that once you have the phenotypes, you can subtract it from 1 and then you have the degree of freedom. The critical value is easily, it's given as well. Why it's given? لأن كده if you look here, sorry, هنا كده, if you look here, those are all the critical values. If you know the degree of freedom, you can get the critical value. Easy wheezy lemon squeezy. And how can you get the degree of freedom? Subtract it from the phenotypes. So each and every one of them is depending on the other. If you get the phenotypes, you get the degree of freedom. If you get the degree of freedom, you get the critical value. If you get the critical value, you can easily compare it to the chi value. كلهم مبنيين على بعض. You can easily compare it to the chi value. طيب. The only thing that you have to memorize is this. If the chi value is bigger than the critical, reject the null. If the chi value less than the critical, accept the null. Okay. Right. Now كده, let's go and start solving some problems found within your review pack. طيب, the key in order to answer any AP question is to read the question very well and get the given out. A student crosses a pure breathing line of red flower, blah, 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 with a pure breathing line of a white flower. The student observed that all the plants in the F1 generation have pink flowers. There's something that I would like to say before heading to this. طيب, what if I didn't give you the chi value? What if I didn't give you the chi value? How can you work that? سهل قوي. Chi value, in order to get the chi value, you must have the sum of phenotypes, chi values of O minus E power of 2 divided E. O represents the observed. E represent the expected. And once again, E represent the expected. Normally, I would give you the observed as given. Normally, I give you the observed as given. But what about the expected? How can I get the expected? Use the Punnett square. That's when you have to use the Punnett square formula. The dihybrid cross or the monohybrid cross, either ways. Okay? If I didn't give you the chi-square value, you have to work it out. You have to work the formula in order to get. And how can you get the expected? By using the Punnett square. Back to the problem. The student observed that all of the plants in F1 generations have pink flowers. Okay, so a red, pure red, plus what? Multiplied by white, and the all given offspring were pink. This is the given, something to give it aside. The student then crosses the F1 plant with one another and recorded observation. Then he took this pink, this is F1, times pink, and then recorded the observation, all of F2. So result will be an F2. The students will use the F2 data to perform a chi-square goodness of fit test for the model of the incomplete dominance. The setup of the student chi-squared, blah, 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 kaza. So those are the observed and the expected. I gave you the expected, so hallelujah, you are not going to use the chi-square formula. And this is the observed. How many phenotype? أول حاجة كده I'm collecting, I told you I'm collecting the given. Those phenotypes, how many different phenotypes? 1, 2, and 3. يبقى الفينو types أو خلينا نكتبها هنا pheno types equal 3. If you know the phenotypes, so directly you have to find the degree of freedom. Degree of freedom equal 3 minus 1, so it's equal to 2. حلو جدا. This is the first given. The critical value for the chi-square test was significant of P probability equal 0.05, another given. And 2-degree freedom, we managed to get this, is 5.5. So he's giving you that the chi value equal 5.99. So no need to use the formula. I already gave you the chi value. Which of the following statement best complete the student's chi-square goodness of fit? طيب, if you have the degree of freedom, if you have the probability to have the chi value, you still want to know the, yes, critical value. How can you know the critical value? By going back to the table. This is the table. Okay, let's clear بس الأول هنا كده كل حاجة. Okay, fine. I know that the degree of freedom equal 2. I know that the probability is 0.005. So I know that the critical value equal to 5.99. Back to the problem. Back to the problem, please. Okay, so the critical value equals to 5.99. So which among them is the best fit? No. Sorry. This is the critical value. There's something wrong. Okay, this is the critical value. Okay. Okay, ماشي. I know the degree of freedom, I know the probability, I know the critical value. Can I get the chi-squared value? Maybe. The calculated chi-squared value is 1.55 and the null hypothesis can be rejected. The calculated chi-squared value is 1.5.3 and the null is rejected. The calculated chi-square is 98 and the kaza is rejected. And the calculated chi is 98 and the null is rejected. How can you get the chi-squared value? You know that in order to get the chi equal O minus E power of 2 over E. And here is the sum. How many phenotypes you have? 3 phenotypes. As if you were going to apply the formula 3 times. Apply formula for 3 times. طيب نيجي هنا كده. Red flower expected 56, pink flower 112, 56. So the first one is equal to O, observed was 64, 56. We can write it here عشان يبقى قريب منا. يبقى أول phenotype equal observed 64 minus 56 power of 2 divided observed once again 64. So that is the first phenotype. Second phenotype is equal to observed minus observed here, that case 107 minus expected 112 over 2 divided by 64. And the third time, you have white flowers, third phenotype, 53 minus 56 over 2 divided, expected. The expected not observed. يعني هنا على 56, 112, and هنا 56 as well. Power of 2. If you calculated all of those, it would be equal and plus them, sum all the results here, it will equal to 1.53. Okay, so 1.53. Now you can compare بقى. Is 1.53 chi value? If the chi value, and this is the critical value. احنا عارفين critical value equal 5.99 and the chi value equal to 1.53. So it is less than, and you know that when it's less than, you have to accept the null. So it cannot be rejected, as if you are saying that I'm accepting the null. So the answer would be A. So this is the answer for question 102. Now question 109. Once again, you have to collect the given and work the problem. In fruit flies, purple eyes and ebony eyes are traits that display autosomal recessive patterns of inheritance. They are autosomal. He's giving you an feedback. In a genetic experiment, Students cross wild type fly with flies that have purple eyes and ebony eyes. The students observe that all of the flies in F1 generation have normal eyes and normal body. Okay. The student then allow F1 flies to mate and produce the F2 generation. He's giving you the setting for the experiment. So far, كده, there is no data. He's giving you the setting. The student recorded observation for the flies in F2 generation and used the data to perform a chi-square goodness of fit test for a model of independent assortment. The setup was like this. Let's bring all the givens. أول حاجة number of phenotypes. I can get the number of phenotypes. How many of them? 1, 2, 3, and 4. So 4 phenotypes. يبقى number 1 الphenotypes equal 4. Therefore, a degree of freedom equal 4 minus 1 equal 3. So I know where to search. So far, I know where to search. A student choose a significant value of P equal 0.1. This is different, okay? 0.01. Which of the following statement best complete the next step for the chi-square goodness of fit? طيب, what other given I'm giving you? I'm giving you the observed. I'm giving you the expected. If I gave you the observed and the expected, you have to work the chi formula. And I'm giving you the probability range and I'm giving you the degree of freedom. From those two, you can get the critical value. And from the chi formula, you can get the sum of the chi formula, yani, you can get the chi value. Then you have to compare the chi to the critical. But this time you have to take in consideration that he's using a different range, 0.01. So you have to use the table, اللي هو a collective table, the big one. Okay, طيب. And if you started to calculate all the data, you would find that the chi-squared value after using the formula, let's apply the formula for every phenotype. How many phenotype? 1, 2, 3, and 4. So number 1, احنا قلنا ان chi formula هي عبارة عن sum of O minus E power of 2 over E, observed minus expected over expected. So the first phenotype, the observed, is 187 minus the expected 171, all power of 2, or power of 2 divided the expected as well, 171. This is the first phenotype. Second phenotype, هتبقى 49 minus 57 power of 2 divided 57. The third phenotype, it would be 41 minus 57 power of 2 divided 57. And for the fourth phenotype, it would be 27 minus 19 power of 2 over 19. And then get all the results and then sum them up. After summing them up, it will be equal to 10.48. So the chi value is equal to 10.48. Right. You know that the P is 0.01, so you have to go to this table in that way. But if I'm asking you to get a different probability value, I will give you another table, 0.01, and you know that there are 4 different phenotypes, yani degree of freedom is equal to 3. So placing it would be equal to 11.34. In that way, just place them, ya shabab. Just place them. So 3, move كده, and then drop up until you get this value. Now the critical value is 11.3, 11.34. Okay, طيب. Back to the هنا. The critical value is 11.34. 11.34 and 10.48, which is bigger. This is bigger, less than. Once again, you have to reject the null. Yes, you have to reject the null. And if you rejected the null, square value is kaza, kaza, critical value is kaza. Okay, in that way, you're asking you only for the for the values type. And the last question. And the last question. Reject the null. Accept the null, sorry, accept the null. Here you have to accept the null. I'm sorry. Accept the null. Okay, right. And the last question, which is 130. In a strain of tomato, blah, 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 a height and the small fruit size are traits that display autosomal recessive. In that way, is giving you two traits, plant height and the fruit size. So, by the way, you have to say that most probably I would be working the dihybrid cross. If he's not giving me the expected, so I have to work on the dihybrid cross. A trait that display autosomal recessive patterns to investigate the traits segregate independently. Cross a pure breeding of tomato have the larger fruit with a pure breeding, short tomato with a small kaza. The research observed that all of the plant in F1 was kaza and all of the F2 were kaza. Okay, this is the setting of the experiment as well. Now he's asking you, the research shows a significance of 0.05, which of the following complete the chi-square for goodness effect. Once again, collect all the given. I'm giving you how many phenotype? 1, 2, 3, and 4. 1, 2, 3, and 4. So phenotypes equal 4, degree of freedom equal 4, minus 1 equal 3, 3 equal 0.05. So easily you can get the critical value. I'm giving you the observed, I'm giving you the expected. So you can work the formula, which is O minus E power of 2 over E, in order to get the chi value. And then if you get the chi value, you need to compare to the critical value. And if you work at the experiment, you would find that the chi-squared value would equal to 9.24, okay? Critical value, I know that it's 0.05, degree of freedom equal 3, go to the table, where is the table? Here is the table, okay? Hina, adi 3, so the degree of freedom is 7.82, let's write here, 7.82, 7.82, which is bigger, here is bigger. So in that way, you have to reject the null. So the answer would be D, the chi-square, sorry, Hannah. A, the chi-square is equal to 9.42, and the critical is 7.2, is independent and can be rejected. You have to reject the null. And that's it. Thank you.